Let's start with the most basic graph. All right. R in this one, R equals 5. Remember what the R meant. That's the distance away from the pole, the center dot, the center black dot there, right? So everyone go to a random angle right now on the curve. I don't care. Pi over 3, 5 pi over 6. Go to a random angle and go 5 units out and plot a point there. All right. I'll do the same thing. Just pick any angle up here and graph an R value of 5, which is 5 units away from the pole, the middle. 1, 2, 3, 4. Everyone should have a point somewhere on the outer edge, right? All right, pick another angle and go 5 units away. That's what R equals 5 means. Go 5 units away from every single angle. So as you don't have to plot every point, obviously, but as we put more and more points 5 units away at every angle, what's it going to end up forming? A circle. And that's what R equals any number is. All right, is a circle with that distance. So there's your first graph, everyone. Congratulations. Your first graph on the polar grid is a circle. R equals any number. All right. What do you think R equals -3?
A little.
All right, again, pick any angle, but now remember, if your R value is negative, where do you have to go? Opposite, right? You got to go opposite. So let's say I'm at pi over 2. Instead of here, I'm going to go opposite. 1, 2, 3. Is it really going to matter? No, I'm still going to have a circle, but now it's 3 units away. So not going to matter if it's positive or negative. R equals any number will always give me a circle. So there's the basic curve, basic graph. All right, ready to get a little nuts. I wish that was as easy. All right, on your calculator first, because you'll notice when we graph, what are these in, degrees or radians? These are all in what? Radians. So if we're going to fill out this chart that's in radians, your calculator needs to be in it. So go to your calculator, hit your mode button. Make sure you're in radian mode, not degree mode, before we fill out this chart. Okay, everyone's in radian mode. Okay, first up, 4 cosine theta. That's what we're graphing now. 4 cosine. You're killing me. Hit your mode button. Up top. Make sure radians is highlighted. All good now?
Yeah.
Okay. Your boy was thinking the same question, but he didn't want to ask me. I could tell.
He got it.
Yeah. All right, so what's this curve look like? Well, I'm always going to give you a table to fill out. Your job is to find the R values and graph the points appropriately. So I'll slow it down. We'll go one by one. So now theta is 0. So everyone in their calculator, 4 cosine 0. 4 cosine 0. And write that number into that column. So everyone's got a 4, right? R equals 4. So the first point we're going to graph is 4, 0. Because that was the angle measure. Remember, we always graph the R value first, the theta second. So where's this on the curve? I go to 0, and I go how many out? 4 out. This is why we practice plotting points. So there's my first point right there. All right, plug in now pi over 6. This is just finding a lot of calculations on the calculator, and then make sure you plot them correctly. So 4 cosine pi over 6. And we'll round to the nearest tenth so we don't get crazy. So what's your R value here? About 3.5. All right, so we're going to graph 3.5, pi over 6. And it's already labeled. You don't need to bother putting it at a 12. So at pi over 6, make sure we go about 3.5 out. 1, 2, 3.5. And keep in mind what order we're doing these in, because we have to connect them in that order when we're done. Okay, we do have to connect them in the same order we plot them. All right, keep going. Pi over 3. All right, go pi over 3, see what you get.
Wait, so it'd be like pi over 6 cosine is those.
4 cosine pi over 6.
Why is it
The pi over, this is all your angle measures, your thetas. So it's going to go in for theta. All right, so the next one we're doing is 4 cosine pi over 3. Everyone getting the 2 out? We getting 2? Two comma pi over 3. Graph it. Again, you guys have a choice. I'm graphing them as I find them. If you want to fill in your whole table, then take your time and graph it. That's your call. All right, either one's fine with me. So 2 pi over 3. 1, 2. If you're not getting these values, let me know. So 4 cosine pi over 2 is up next. What number are we getting out of there? So I know we're on the right track. I'm not getting, I already got 2 out for pi over 3. I'm getting 0 out when you plug it. All right, quickly here. What's that point going to look like? 0 pi over 2. Where's that point going to be?
In the middle, in the center.
Pi over 2. I don't go anywhere. I stay right here. 0. Don't move. So it's right at the pole. So there's another point. Okay, now we have to start being careful now, because the next value, what are you guys getting for 2 pi over 3? Yeah, -2. Got to watch yourself, because you got to remember the rule. When the R value is negative, I go on the opposite side. So I should not be putting a point anywhere on 2 pi over 3. It should go on the opposite side. So 2 pi over 3, it actually should go on. I can never do this visually. What's that across from? 5 pi over 3?
11. Yeah.
It's across from 5 pi over 3, right?
Yeah.
So that's where my 2 should be going.
Next one is 11.
Watch out for the negative R value. And then eventually here, you guys are going to start noticing something. All right. 5 pi over 6, I get -3.5. Again, opposite, go opposite 5 pi over 6.
11 pi over 6.
Yep.
Oh, go figure. Oh, go figure.
And then watch what starts happening right now at pi. What are you guys getting for your R value when you plug in pi for 4 cosine theta? -4, right? And if you try to plot that, go opposite what's already there. What's already there?
To 0.
And that point's already there. We've already graphed it, right? It's the same point, right? Because if I go pi, it's -4, so I go in the opposite direction. 1, 2, 3, 4. That was the first point I graphed. So now you're going to start seeing, oh, I've already graphed these points. But keep finishing here. 7 pi over 6, -3.5. And you'll notice if you go opposite 7.6, we've graphed that already. That's been graphed. Are we seeing that? Because it's going to get a little bit more complicated by the end of class. 3 pi over 2 is 0. We've already graphed that at the pole. I should be asking, you guys know where the pi button is, correct? Right above the division sign, and hopefully you're using a fraction template to find all these. And then I get 2 at the end. And that also has been graphed, correct? Yep, 5.32. So what's this going to look like? Yep, I get a circle. And I'll show you when we're done with the next one. Relax, relax. I'm going to show you at the end of the next one how you can tell where on the graph the circle is actually going to be. All right, you can actually tell right now. See how the number 4 was out there? It went out to 4. All right, that number out in front will tell you where it goes and how you know it's a circle. I'll tell you all that at the end. Any questions here? Go ahead, Jake.
Would there not be a line from the -3.5 to 0?
No, because that's what it's going to. It's just going to be a circle. Because I skipped some values in between, so that's why there would be more values that would connect all those. Yep, good question. All right, let's go. Let's keep going. We got a bunch to graph today. This isn't like a 10-minute lesson. All right, 6 sine theta. 6 sine theta. Let's go through it again, and at the end I'll say, hey, this is why it's a circle. This is where you know it's going to be. All right, now we're doing sine now. So plug in 0. What do we end up with? 0. So where's this first point going to be? Right at the pole. Pi over 6 should be at 3. So at pi over 6, I'm going out 3. Again, remember the order you plot them. If you guys prefer to fill in the table, then plot them, your call. I'm getting 5.2.
Just kidding.
No.
Just make sure we're matching if you're getting ahead of me.
Yeah, and then you can drink it up. Yes, I do. Something like this.
Yeah, I don't believe that you told us.
I did. I told him.
You took her coffee.
I'm drinking the coffee and then instead 2 minutes before I'm getting this my coffee to make because I'm done with it.
So far, I'm not getting any negative numbers yet, so no need to go on the other side. I'm at 5 pi over 6.
You guys.
Now it makes up some
You need some lemon. I have some. It's not good to try. It's not good. Oh.
So everybody got
I can't
0 pi. So now I'm back at the pole again. All right, let's see what happens after pi. I get -3. So if I go to 7 pi over 6 and go on the opposite side 3 units, I graph that point again. So it looks like we're starting to repeat ourselves after pi.
Do you make a circle with all the dots when you're done?
After you're all done and you figure out that 3 pi over 2 and 5 pi over 3 are the same points. And I know it doesn't look like a circle, but also know we didn't graph points in between either. And actually, one of my points is off. This is on the wrong one right there. 1, 2, 3, 4, 5. There we go. If we graph more points in between the ones we graphed, it would look like, thank you. It would look like a circle. Okay. All right, let me stop. Hold on because the next one's a totally brand new one. All right. Anytime you have a number times sine or a number times cosine, and that's it, it's going to be a circle every time. How can you tell where it's going to end up? And you guys probably don't remember. If you do remember this, this would be unbelievable. before we took the Regents exam, so probably like November, December. Cosine is always related to what coordinate? Good job, yeah. Wow. Wow. The x coordinate. Hey, take a look. See what axis it's on? It's on the x-axis. Okay? If I put a -4, come on, be big. If I put a -4, guess how this graph would change?
To the left.
There you go, big dog. There you go. It would be on the opposite side, the negative side of the x-axis. Okay? So if it's cosine, it's on the x-axis. If it's sine, it's on the y-axis. All right? And it's always a circle if it's 6 or if it's any number times sine or any number times cosine. Automatic circle. Good? So that's a circle. Oh, now we're really going to get heavy now. Buckle up. This is what I've been waiting for all unit. Look at this. 5 minus 5 sine theta. Not a circle anymore, right? Because I added in that little part right here. All right? So let's graph it and see what we got. Here we go. This is what I've been waiting for. It's not going to be a circle because it doesn't come, if I covered up the 5 minus part, that's a circle, right, on the y-axis, but now I put 5 minus, not anymore. Here we go. Let's see what it ends up being. Plug in 0. Oh, Alex, make sure you're in radian mode, okay, because these are all radians we're plugging in. So let's plug in 0. Everyone's getting 5 out, right? All right, so let's go 5 away on 0, 5, 5, 0. Got to take your time on this one. All right, next up, what do we got? About 2.5. Two and a half comma pi over 6. 1, 2.5. All right, be careful on this next one because we get a small value, right? When you plug in pi over 3, you get about 0.7. So just below the first circle. Be careful when you graph it. It's a small point. Or a tiny distance. So 0.7, about right there. And then we get 0 for pi over 2. Everyone's with me so far? We're all good? All right, going to 2 pi over 3. I get 0.67 or 0.7 again. No negative values yet, so we're not repeating anything. No negative values yet.
When did that happen?
2.5 next.
No, it's definitely not.
Oh yeah, here we go. 5. No repeaters at all.
Aaron, did you do something wrong? Okay.
10. No, I don't think so. I think it just lands right on, doesn't it? At the end. There's 10 circles total here. So it should land right there.
Yeah,
I don't need to spend
It's like a heart.
With
Your secret life, or did you like?
That was tricky.
So hopefully none of the points repeated themselves with all fresh points before we graph this bad boy in. And what do we end up with here, huh? Wish I knew what one of these were.
What's so hard?
So that's the thing.
Or bungee.
Where's
Yes, you can think of it as a heart, the official name, cardioid. Or cardio, heart, yeah. Cardioid graph. That's what this is called. Cardioid.
Is there a name for Jared's
Oh,
second
no.
answer?
No, sorry.
The facts you add.
So you could think of it as a heart, yep, cardioid. Now, how could you tell just by looking at the equation that you're going to get this type of graph, the heart, the cardioid? The numbers always match. If the numbers match, I don't care if it's plus, minus in between, or sine or cosine, it's always going to be cardioid if the numbers match. Right? That's called a cardioid graph. Looks like a heart. All right? All good? Cardioid. When you add and subtract the same number. And then the last one we're going to do, that's not going to be a heart. I can tell you that because the numbers don't match. So we got another name for it. Watch this bad boy here. All right, go ahead. Go to your chart. Start filling out your chart. I'll let you guys get a couple minutes. If you decide to go ahead of me and graph it, be careful. All right, you're not going to get a heart here. You're not going to get a heart.
What we're talking about.
What's it going to look like when the numbers are different? We can make a good guess since it says cosine. What axis is it going to be on? Should be on the x, right? Yeah. And that's exactly where it's going to be, the positive side of the x.
what if we were?
Ooh, why are we going there?
That's what.
I think we'd have fun there. We'd make friends.
I'll start writing in my values.
Nice to see you there.
That was great.
And who? She's the CEO. She is the headmaster. Did you want orange with the new book?
No.
I love that shit.
How about this one, huh? Make sure you connect them in order so you can really see what this looks like.
Gosh, man.
She's not welcome. I'm gonna make that clear. If I agree. Remember?
Kate's coming. Her husband. You gotta account for that.
Oh.
Nicole is gonna have a fit. That's what's gonna happen because I didn't tell her about any of those.
Watch out when you start the negatives. Got to go on the opposite side.
That's her boyfriend.
What?
Yeah, she dates his husband.
Keegan's it's her cousin. Like you're being serious.
Yes, the one that I wrote down.
It's her cousin.
No.
Yes. You guys didn't know this?
Wait.
I'm joking. I don't
You
believe
sat
you.
and had a dinner with the kids.
No, but why? No.
They're not cousins. I don't believe
They are cousins.
Is there dating?
No!
Oh,
You're just
you
saying.
You just
literally
said
just
that.
It's Taryn's cousin.
You never
Oh, yeah.
Yeah, which means she's gonna show up and that's not happening.
No, she's not gonna show up.
She should.
Monty? Not
You,
helpful.
we're calling you.
I'm gonna pick her up. Trip her up.
You're picking her up and dropping her off.
No.
Make your done.
And then you say we'll sprawl.
I spent my baby.
Yeah, he said, yeah, Mason, he's ready. I texted him yesterday, and I told him, I said, better get dressed up. They want to take pictures of you. He said, oh, okay, I can do that. He's excited.
I'm wearing green, so I want to pick something up.
I'll let him. I don't know what I'm gonna do next. Kind of like too many decisions I didn't think I was gonna have to make because I thought she had.
Yeah.
Are you supposed to round up the
I
nearest
thought she
half
had it
already?
already.
I went nearest 10.
Yeah, that's what I thought.
Which one you looking at?
Yeah, so she's definitely here and beyond.
Oh wait, actually, never mind. I can't.
That's what's gonna happen.
Okay.
And Nick doesn't like her, so
I don't blame Nick. I blame Nick.
it'll go.
I side with Nick.
Yeah.
Not you.
Yes.
Well, maybe you two.
Yeah.
I don't know.
I out of you and Aaron, I side with you.
A little different than a heart, huh?
We're not divorced from me and Aaron. So, my sides.
I don't even know what order I go by.
I haven't talked to it yet. I'm writing it down.
Five. Here.
This really puts my feelings.
We know you can't
I
count.
cannot count.
I missed
Just
the whole
say
point.
anyway. Yes, if I knew how to count.
I missed like 7 points. Oh no, I didn't.
Hang on, Aaron. I'm still counting.
It looks like a weird whistle.
A weird what?
Whistle.
So you're getting a weird shape too, okay? Because right now I'm getting a star.
And hey,
Wait.
little loop-de-loop. Take a look.
Oh, so.
I'm just messing with myself.
If you'd like to, I'm sure, impress everyone later on, we had a cardioid, right? That looked like a heart. Now when the numbers are different, ready for this one? Lima-san. Let that roll off the tongue a couple times. Lima-san. And I don't even know, this is how you spell it, Lima. I don't even know what the heck is below that C. Anybody? Better English majors?
Spanish.
Lima-san.
Yeah, it's in Spanish.
Right, so we had circle, cardioid today, and now Lima-san. One more to go later on in the week. Your old crow's curve.
I know that.
Sure.
You're such a liar, you do.
I actually don't know.
You're such a liar.